Our conclusion. Firstly, our initial portfolio beta is 0.78, which is smaller than 1, meaning our portfolio is non-aggressive and it has lower risk. After we do shrinkage estimation, our portfolio beta increase. That means the portfolio will be more risky and volatile. Secondly, in EMWA method, if we choose lower lambda, we will have more past information and it will become more fluctuated. If we choose larger lambda, the beta will be more stable. And then move to our factor model project. First, we use campaign model, and here we will get 20 beta zeros and 20 beta ones in total. And then we do pharma and French model. Here we add 2 more predictors. One is SML, small minus large, and another is HML, high minus low. So in total, we will get 4 betas for 20 risky assets. And we choose other factors. The one is RMW. RMW is the average return on the 2 robust operating profitability portfolios minus the average return on the 2 weak operating profitability portfolios. And it has the form like half times small robust plus big robust minus half times small weak plus big weak. And second, we choose crude oil index from Bloomberg. We think this crude oil could be the input of production, so that it will correlate it to the economics directly. And then we do campaign including F1, campaign including F2, campaign including F1 and F2. We also do French pharma including F1, French pharma including F2, and French pharma including F1 and F2. Here is the expected return for the different models. From the graph, we can see that those models give us similar data returns for each asset. Almost all of these assets keep the positive returns for 4 models, but WFT has negative expected return because the price of WFT decreases a lot during that period. And F4 is a special case because it has positive F and F return as well as F plus F1 and F2, but for all other predictions it is negative. And we also do return variance. We can see the variance are small among 8 models, and different models are kind of similar with approximately same magnitude. The return variance measures how fluctuate the stock performed. And for AMD, VALE, WFT, these 3 assets, we have relatively higher variance, especially the actual variance and FF plus F1 and F2. And we do covariance of return. We compare each model respectively with another model or themselves. We calculate the corresponding covariance by using second norm. From that, we can see the magnitude of the matrix norm as relatively small. That means we can use those models to do more prediction, and prediction should be somehow accurate. And here we choose 2 models. One is campaign model and one is pharma French to compare with the historical return. We can see that the historical return is the highest one, and the campaign is the lowest one, while the FF plus F1 and F2 is in the middle of these 2. Here the plot, we use the annualized return to analyze. And we can see that FF plus F1 and F2 is similar to historical data. That means our F1 and F2 are good predictors. here is the actual return for a chosen model. We can also find the historical has the highest actual return and the CAPM model has the lowest return. The return variance is also the same. Historical data has the highest variance, while the CAPM has the lowest variance. From that, we find the historical data has the best performance in return with the highest return variance, while the CAPM model has the worst performance and the lowest return variance. And besides, we also find F plus F1 and F2 is somehow good model to predict, and that means our F1 and F2 is good predictors. And here is the covariance. We use the historical and FF to calculate the covariance. And the final part is quantile-based portfolio backtesting. Here we listed 20 assets sequentially by using Sharpe ratio. The top 5 is the 5 has the highest performance, and the lowest 5 is the 5 assets with worst performance. And we choose equal weights to long the top 5 and short the worst 5. Here is the result for return performance. We can see that quantile-based portfolio has the return much more higher than the Markov with optimal portfolio. That is because we choose the top 5. We improve the model by adding more highest performance assets and short more worst performance assets. And the conclusion, if we have to choose one model to implement, FF plus F1 and F2 could be a better choice because it is more similar to historical data. And from the plot, we can see that quantile-based portfolio has better performance than the Markov with optimal portfolio. That's it. Thank you.